This is lesson 3.1 on solving inequalities using addition and subtraction. So here's a scenario. If you need at least a 92% on the Chapter 3 test to receive a 1 at mid-quarter, what grades would be acceptable? And we're going to write that as an inequality. So if you think about it, if you needed grades of at least a 92%, you could have things like a 93, a 95, a 97, 99, 100, and so forth. So could you have a 92? If it says at least, absolutely. So that's the smallest value you could have and still get a 1 at mid-quarter. So you can have anything that's at least 92 or larger. So if we use n as our variable, we would have to say that n either has to be greater than or equal to 92. Now, our terminology here said at least, which seems kind of strange because it's greater than or equal to. But if you think about it, it's got to be either 92 or something larger than 92 would enable you to get a 1 at mid-quarter. So if we graph this, I typically have you put at least a 0 on there. And then 92, a positive 92 would be over here to the right. And we would put a circle at 92 to indicate that 92, if we fill that in, that 92 could be a possibility. And then it could be anything larger than that also. So graphs are a great way to express that amount because it's too difficult to list all the possible scores that could happen. So we're going to move on to this next page. So our first inequality, now with inequalities, we're going to have one of four things. We're either going to have less than, greater than, less than or equal, or greater than or equal. So our first one, these are going to be solved a lot like equations, except there's no equal sign there. You're going to have an inequality in its place. So we're going to solve for x, and we need to get rid of that 11, so it's plus 11. We're going to minus 11 from both sides of our inequality. So x is going to be anything greater than 5. So I'm going to put a 0 here. I'm going to go over 1, 2, 3, 4, 5, and I'm going to put a circle of 5. I'm not going to fill it in this time because I don't want to include 5 because it doesn't have the equal sign underneath. So anything greater than 5 would cover anything in this category. So our arrow is going to go to the right and our circle is not going to be filled in. Okay, we'll go ahead and work out these two. We're going to solve for y. So to undo plus 4, we're going to minus 4 from both sides. So we end up with y is greater than negative 6. So this time I'm going to want to put my 0 over on this side. I'm going to go over negative 6. 1, 2, 3, 4, 5, 6. And it says it has to be greater than negative 6. So we're going to put a circle at negative 6, meaning it doesn't include negative 6, so we don't fill in the circle. And all things bigger than 96 would, or excuse me, bigger than negative 6 would go to the right. We could even check a few things. So if this kept going, like 1 would be over here. So if we threw 1 in here, is 1 greater than negative 6? Yes, it is. Any positive number is bigger than any negative. So this next problem, we're going to have to combine our variables. So I'm going to subtract 3r from both sides. So we have 6 is greater than 1r. Now, when you read inequalities, you're going to read them from the letter on. So in this case, we would read it this direction. So this says r is less than 6. You could even rewrite it like this, r is less than 6. So those say the same thing. I think sometimes it's easier to graph it if you just rewrite it so it looks like this. So we're going to go ahead and put 0 here. We're going to go over 6. 1, 2, 3, 4, 5, 6. And it's anything less than 6, but it doesn't include 6. So we're not going to shade that in. So your graph would look like that. We're going to skip over this one and go to one of these. So let's go, we're going to do this one down here on the bottom. So we're going to minus 3, minus 3. So k is less than or equal to 1. So I'm going to go ahead and put a 0. and a 1 to the right since it's positive. So now remember, we read it from the letter. So it says k less than or equal to 1. We're reading it this direction. I'm just going to rewrite it because I think it's easier to look at this way. It says the same thing though, since we read inequalities from the letter. So k is less than or equal to 1, so we're going to put a circle here at 1. This time we're going to shade it in. I always tell the kids this little line here says fill in the circle. So we're going to go to the left. All right, the final one we're going to do on this page is this n minus 2.5. So we're going to have to add 2.5 to both sides. So we end up with n. I'm going to go ahead and add a decimal and a 0 so that I can line up my decimal places. If I subtract those two, I end up with a negative 2.5. So I want to express anything greater than or equal to negative 2.5. So I'm going to throw a 0 in here. If this is negative 2, negative 2.5 would be about right here. So we want to indicate that on the graph. And it says it's greater than or equal to negative 2.5. So I'm going to have to shade that in. That little line underneath our inequality tells us that we need to shade in right here. And it's anything larger than or equal to that amount, so it's going to go to the right. All right, we're going to cruise through these to this section here. So we're going to define a variable. That's one thing. So like n or x or whatever we want to use. We're going to write an inequality. So one of those 4 inequalities we talked about. And then we're going to solve. This one does not say that you have to graph the inequality, so we're not going to do that. So our first part says twice a number, which would look like this. Minus 4 is less than. So that just looks like that. Is less than 3 times the number. So we're going to go ahead and get our n's together. Since I already have n's isolated on the right, I'm going to take this 2n over to visit the 3n by subtracting it. So we did the opposite operation. So we now have negative 4 is less than 1n, which means the same thing as n is greater than negative 4. And I'm just going to rewrite that as n is greater than negative 4. Remember, we read it this direction. We don't have to graph this one, but I do want to kind of do a mental check. If I think of anything greater than negative 4, like 0 is greater than negative 4, I could throw 0 back in this original part of my inequality. If I throw 0 in for n, it's going to look like this. So that's 0 minus 4 less than 3. So it's really negative 4 is less than 3, and that is true. So that does check out. So don't forget to do the check on those. I'm not going to do the check on the rest of these. I just wanted to show you an example. So number 2 says 12. Well, that's pretty easy, 12. And then it says is at most. Now, I always tell the kids to think about this and think of it in terms of cookies. If I say that Jeremy has at least 40 cookies, or excuse me, has at most 40 cookies, Jeremy's not going to have more than 40 cookies, but he could have less than 40. So at most looks like this. They can have 40, but it could be less than or equal to. So you're really on these looking at what does at most mean. At most actually means less than or equal to. So it is at most a number decreased by 7. So there's your inequality. Now we're going to solve by adding 7 to both sides. So I now have n greater than or equal to 19. So I'm going to rewrite that, n greater than or equal to 19. And our third and final says the sum of a number and 17, sum means to add, is no less than. Now let's go back to the cookie thing again. If I say that Susie has no less than 26 cookies, it means she has at least 26 and could have anything bigger than that. So no less than means greater than or equal to. So be real careful on the wording of those. They're easy to mess up. So minus 17 on both sides. So we end up with n greater than or equal to 9. And that's it.